According to the Bohr theory, in earlier videos we discussed about the spectral series and as well as the radius of orbitals, means whenever the electron is revolving in a stationary orbit, it does not radiate any energy, and we already derived an equation for that expression for the energy difference, that is E2 minus is equal to h nu. From that equation we already find out that mu is equal to 1 by lambda is equal to r of 1 by n1 square minus 1 by n2 square be the equation to know the wave number and the wavelength of an electron, when a wavelength of the path whenever the electron is revolving around the orbit, and the energy levels, means when electron is revolving around the nucleus in a stationary orbit. In that case of Bohr has given his postulates, the second postulate of a Bohr explanation is suggested, means is confirmed by, is supported by the Debroglie by his new concept, that is Debroglie hypothesis. The Bohr's second postulate, which is the total angular momentum of an electron, which is equal to an integral multiple of h by 2 pi. The Bohr's second postulate is there. By suggesting that one, by he has given his new concept, that is Debroglie hypothesis. According to this Debroglie hypothesis, here when electron having the mass, this is the nucleus, and electron is revolving in a orbit, and which is having the mass m, and it's moving with velocity v and is associated with a wave. According to the Debroglie, whenever electron is revolving around the nucleus in a stationary orbit, it is considered as a particle, it must be a particle wave, means associated with a stationary wave, means here whenever it is revolving around the nucleus, it will be in like a wave form, it will be moving like a wave form of its wavelength is Debroglie wavelength is lambda, means whenever it is traveling, the distance between them is equal to the wavelength, and this will be the radius. So in case of, according to the Debroglie hypothesis, an electron of mass m moving with velocity v is associated with a wave whose wavelength is lambda, means according to the Debroglie, whenever the electron is revolving around in a stationary orbit around the nucleus, it must be moving in a particle wave, like a particle wave associated like with a stationary, that is stationary wave, with having its wavelength is lambda. So that case of its wavelength lambda is having the value for h by mv, h by mv, means h by mv we can write it is also lambda is equal to h by p. P is the momentum and h is the Planck's constant and lambda be the wavelength. So here h be the Planck's constant of value 6.6 into 10 to the power of minus 34, joule second be the Planck's constant value, its value is a constant 6.635 into 10 to the power of minus 34 joule second be the equation value for the Planck's constant. So on the basis of this hypothesis, he proposed an atomic model. In which a stationary orbits of the Bohr's model, means Bohr has given that whenever the electron is moving around the nucleus in a stationary orbits, the stationary orbits are non-radiated paths, means whenever it is moving in a constant orbit, no energy can be radiated. So in that case of whenever according to the Bohr's model, he proposed an atomic model by which the stationary bits of the Bohr's model were retained, because of whenever it is moving in the stationary orbit, its wavelength cannot be calculated. Whenever it is completed its circumference, then only it can be said as the total its circumference will be 2 pi r, so that it will be destructive interference will be happen. So that in case of that the Bohr's model were retained, but with the difference that electron in various orbits means in various orbits behave when electron with the hypothesis here, the atomic model in that case of stationary orbit, the Bohr's model has retained, and also that were retained Bohr's atomic model was postulate with the difference in the electron in various orbits behaves as a wave. So that he suggested that the stationary orbits are those in which orbital circumference, whenever the orbital circumference 2 pi r, we know that orbital circumference 2 pi r, L is equal, length is equal to 2 pi r. Whenever the electron is revolving, if it completed one circle, then it will be is equal to, along the circumference will be 2 pi r. Orbital circumference is 2 pi r, is an integral multiple of de Broglie wavelength. It is an integral multiple of de Broglie wavelength. Means the number of wavelengths are completed. This one wavelength, two wavelengths, three wavelengths, and means is equal to number of wavelengths, which is equal to L is equal to 2 pi r. If in case of this is equal to 2 pi r is equal to how many wavelengths are there? Number of wavelengths. Here the 3 wavelengths are taking, we are taking the 3 lambda. Means if in case of here is that along the circumference, in this case of in this orbital, the length is L is equal to 2 pi r, then 2 wavelengths are 1, 2, means 2 pi r is equal to 2 lambda. Like that, here he suggested the stationary orbits are those in which orbital circumference is an integral multiple of de Broglie wavelength. De Broglie wavelength is 1 lambda, 2 lambda and 3 lambda, means number of integral multiple of de Broglie lambda. So that's why we can raise that the stationary orbits for an electron. The stationary orbits for an electron are those which contain the complete waves of electron. Means wherever it is completes one wave, then the stationary orbits for an electron are those which contain the complete waves of electron. So that's why from that we can write that the circumference is equal an integral multiple of de Broglie wavelength, that is n lambda. So that 2 pi r is equal to n lambda. But we know that the wavelength of lambda from the equation, this one lambda is equal to h by p, lambda is equal to h by p, p is equal to momentum. We know that from the p is equal to momentum, p is equal to mv. So from that equation we can write that lambda is equal to h by mv, lambda is equal to h by mv. So here it is that lambda we are substituting in the equation, that is 2 pi r is equal to n lambda in that case of lambda, but we know that lambda is equal to h by mv. Whenever electron revolving around the nucleus, then it is having the mass m and we moving with velocity v of it in a wave form of wavelength lambda. So that's why lambda is equal to h by mv. From that equation, but we know that we are substituting in the equation, then 2 pi r is equal to n into h by mv. From that, whenever mv taken to this side and 2 pi taken to this side, then it will become mvr is equal to nh by 2 pi. We know that equation, this is the Bohr's second postulate, that is the total angular momentum is an integral multiple of nh by 2 pi, h by 2 pi, that is the second Bohr's postulate. We know that. So then they suggested that here mvr is the angular momentum of an electron and h be the Planck's constant, n be the number of orbits where n is equal to 1, 2, 3, means this is the first orbit, this is the second orbit. If in case of another orbit is there, if we consider that if n orbital is there, then the electron is revolving in a wave formation like this. If it is having the more wavelengths, then the wavelengths are integral multiples. So that's why here 2 pi r is equal to n lambda. N means n is equal to first orbit, second orbit, third orbit, that is goes on. So that from the equation we can get that mvr is equal to nh by 2 pi. Mvr is the angular momentum of an electron, moving electron, and this equation is nothing but a Bohr's postulate, that is the total angular momentum of the moving electron. The total angular momentum of the moving electron is an integral multiple of h by 2 pi, is an integral multiple of h by 2 pi. This new concept de Broglie confirms the Bohr's postulate. This is about de Broglie hypothesis. Once again, according to de Broglie hypothesis, an electron of mass m in motion with velocity v is associated with a whose wavelength lambda, means it's having the wavelength lambda, lambda is equal to h by mv, h is equal to Planck's constant, means electron is revolving around the nucleus and its Planck constant value 6.6 into 10 to the power of minus 34 joules second. And according to on the basis of this hypothesis, he proposed an atomic model that in which the stationary orbits of Bohr's model are retained, but the difference that electron in various orbits behaves as a wave. Electrons in various orbits behave in a like a wave. Whenever the electron is revolving, the wave means it must be a particle wave. It must be a particle wave that is a stationary wave. It is having the wavelength lambda, number of integral multiple of lambda. So that's why he suggested that the Debroglie hypothesis, according to this, they suggested that the stationary orbits are those which orbital circumference, that is 2 pi r, orbital circumference, that is 2 pi r, is an integral multiple of de Broglie wavelength, means 2 pi r is equal to lambda. This is integral multiple of means where n means n is equal to the number of it is goes on. So from this, the stationary orbits, those which orbital circumference, this orbital circumference, that is 2 pi r, is an integral multiple of de Broglie wavelength, that is the stationary orbits per an electron, or which contain the complete waves of electron, means number of waves. Here 1, 2, 3 is there, and 1, 2, 3, 4, 5, 6, 7, like this. Means number of waves are contained by the whenever the electron is revolving in the orbit. So that here by substituting the values, but we know that lambda is equal to h by mv, then we can substitute the equation, we can get the equation, that is by the calculation, that is mvr is equal to nh by 2 pi. From this nh by 2 pi, we know that that equation is nothing but Bohr postulate. In the Bohr postulate, that is mvr is equal to angular momentum of an electron. So that equation gives that the total angular momentum of the moving electron is an integral multiple of h by 2 pi. That is a new concept of de Broglie hypothesis, as confirms the Bohr postulate. So this is a de Broglie hypothesis.